Okay, two resistors. Two resistors are connected in what? So what's another name for series? Chain or train. They sound the same, okay? So they rhyme. So two resistors are connected in series within a circuit, which means what? Probably the circuit is bigger than that, but we're only looking at those two in a chain. That's it, for some reason. After connecting the circuit to the battery, somewhere along the circuit like this, maybe everyone, look. Can you tell me which two here are connected in series? We're gonna get to this. Which two are connected in series? You have that sheet. Number 7, I think. Yeah, number 7. Which two are connected in series? So this one and this one, right? Exactly. So for some reason, we're only looking at this, but we have to still connect this battery to power the whole circuit. Okay. So after connecting the circuit to the battery, a voltage difference of 15 volts only, everyone, between here. Like if you connect one hook here, and one hook here, you actually get what you is it? If you connect one hook here and one hook here, you measure how much? How much? 15 volts only. Okay, so that part of the circuit generates a voltage difference of 15 volts. Yes. Yeah. This is a mix and match. Yes. We'll get to that. Don't worry. Don't worry about that. Okay. Was measured across the in series arrangement. Also, within 1.4 seconds. So we have what? We have time information now. We somehow it was observed or known that 3.25 times 10 to the 16 electrons have passed through one of the resistors. But here's the thing, they're connected in what? Which means if 3.25 times 10 to the 16 electrons pass through one resistor, how many are going to pass through the other resistor? Different or the same? Because is there a split? No, all of the electrons moving will also move through the whole like the complete combination. One of the resistors had a resistance of 1.40 kilo ohm. Draw a representative diagram of the problem, label as many things as you can. Okay, so just like we did yesterday. All right, so how many resistors only? 2. Okay, so here it is. 1, 2, and that's it. Okay, go ahead. Come on, everyone, copy. Okay, 2 resistors, done. How would I indicate that 15 volts is measured? Through the whole thing. Sorry, not through, across the whole thing. Think of what me, Tariq, and Nadeem did yesterday. Yeah, Leila? Because you need how many hooks for voltage? 2 hooks. Okay, so I'm going to use a different color. So from here, or between here and here, we measured in this device, we measured how much? 15, bigger, 15 volts. All right, 15 volts. Oh, just to give you the sense that I actually connected a device. That's all. All right, number 3. Within 1.4 seconds, it was observed that this many electrons passed through one of the resistors. Do we know which one? Do we care which one? Because it will pass through the other one as well. So I'm going to choose, for example, actually, let's label them. Let's call this, for example, R1, and let's call this R2. By the way, do we know that they're equal or potentially different? Okay, so we're going to call them R1, R2. Okay, I'm going to choose this one, everyone. I'm going to choose this one to be the 1.4 kilo ohm. Again, complete random choice. 1.4 kilo ohm. Okay? And how many electrons are running through it? But is it also running through the other one? Also, is it running before, in the middle, and after? So can I just put it in the middle and understand that it stands for the whole thing? There you go. So I'm going to put it right here. So yeah, I'm saying that the current comes from the left and goes into the right. It doesn't matter if you switch the direction. 3.25 times 10 to the 16. Is this coulombs or E's? E's. It says E's, and also it's a big number, so there's no way this could be coulomb. E's. Let me just check. I just got to check this. Okay. All right. Any other information I can put on, or did I put in everything? What do you think? Hmm? Yeah, times 10 to the 16 is. Oh, the time. Sorry. Yes, the time. Where could I put the time? Does the time have to be exactly on the circuit or somewhere on the diagram? Somewhere on the diagram. Okay, so I'm just going to put delta t here. Delta t equals 1.4 also. That's it. Full marks for the diagram. By the way, could I build this right now on the website? Yeah. Okay. You know what? Let's do that. All right. I think it's here. I'm gonna use this one. All right. Resistor, resistance. Oh, there might be a slight problem. How much is my resistance? One of them? 1.4. So 1400. This one, sadly, only goes to what? Oh, only goes to what? Okay. Here's what we're gonna do at the end. We're gonna 1400, 140. You know what? Let me. I think I can use this. Oh, okay. I can use this one. All right. Okay, fine. We'll use the switch. All right. Okay. They're connected in series, right? All right. Delete. All right. Oh, there we go. Is this it? Everyone, look. Are those two connected in series? This one and this one, are they connected in series? Yes. It doesn't matter if they're. By the way, is there really a loop here or just a kink? Just basically a turn. So it's still connected in what? In series. So how much is this one? Ah, gonna make this one what? 1400. Okay. How much voltage? How much? 15. Do I know how much this is? Do I know how much current is running through yet? No, I don't. Okay, let's look at the example now. All right, question one. What's the current? Tell me equations. By the way, I'm teaching you how to use like a formula sheet. Tell me equations that have current in them. Got it. So there is what? There is I equals Q over what? Do I have information for this? Do I have enough information to use this? I do have time. Do I have Q? Do I have an equation for Q? What was the first equation I taught you in this course? Sorry, in this unit. Q equals Ne. Do you have the number of electrons? You see, you have everything. It's just embedded way deep down. All right, so V over R. There's a problem. I don't know the other resistance. And I only know the V across both of them, not just one. Okay? All right, so this is the equation we're going to use. All right, so that's equal to what? Ne over delta T. All right, let's do the numbers. 3.25 times 10 to the 16, because Q is always Ne. Oh, because that's the definition of current. Current is always the charge passed over time passed. Times 10 to the what? 16 is it? Okay, 16 times 1.6 times 10 to the negative 19. That's a non-negotiable charge of a single electron over what? 1.40 seconds. All right. I'm just going to put it here because I'm probably going to need to play with the scale. All right. Where is my, can someone do this with me as well just to check? Okay, here it is. So we have 3.25. Please use the X button to make your life easy. 16 times 1.6 x 19 with a negative. and then divided by 1.40 or 1.4 mathematically, they are the same. There we go. What's the sig fig situation here? How many sig figs right here? 3. By the way, do we care about the sig figs here? No, because it's a constant. How many sig figs here? Great. So 3 for the final answer. So what would this be to 3 sig figs? 3.71. You make the cut. Nothing happens because there's a 4. Nice. So 3.71 times 10 to the negative 3 in what? In amps. But it wants it in what? Is it already in milliamps with the unit, with the scale? Nice. 10 to the negative 3 is a what? Is a done deal for milli. So 3.71 milliamps. So remember, this guy right here is exactly, yes, is exact, yeah, otherwise it would be mega. Is exactly this guy. That's all we did. I just like. Okay. Any questions so far? Remember, today is the last day to do electricity and circuits. So please make sure you get as much done and understood as possible today. We're good? We're doing a review slash beginning of magnetism. Okay, next question, everyone. What is the equivalent resistance of both of them together? Okay, what equation do I have that has resistance, equivalent resistance? Sorry, just resistance. There's only one equation I taught you that has resistance in it. Okay, but that's what? That's for equivalent resistance. I'm just talking resistance in general. Or V equals IR, basically Ohm's law. Okay, do I have the voltage across one of them or both? Perfect. So remember yesterday when we said I section equals V section over R section? That's exactly what we have to do now. Only the section. All right, so I'm going to say V, second. I said, okay, you can either look at each resistor by itself or the whole section together. We have information for the whole section. So we know that there's 15 in the whole section or across, and there's 3.71 milliamps going through the whole section. But that's coming up in the next question, not now. Everyone, listen up. Everyone, eyes on me. This question here, is it asking for the missing resistor or both of them together? So I have to use the whole section. Okay, so V section equals I section times R section. Yeah, again, you are 100% right. It is V equals IR. But I'm trying to show you that you can always apply V equals IR either to a single resistor or to a what? Or to a section. That's important. That's why, by the way, if you do this as a test and you do not write section as a subscript, you get full marks as long as you use the values for the section. I'm just trying to show you that we're applying it to a certain what? A certain location. Someone had a no? Okay. All right. No, you said something about the current. Yeah. The voltage is 15 across both of them. Yeah. So why are you Oh, I'm not looking for it. I'm using it. I'm using the voltage, using the I to find the R. Okay? Yes, because the only thing I don't know about both of them now is the R. All right. How can I rearrange this? R equals what? V over. Great. So that means R section equals, what's the V across the whole section? 15. And what's the I we just calculated through the whole section? Yes, through the whole section. This is it. So 3.71. Is it just 3.71? No, that's in millis. I can't do that. I have to put times 10 to the negative 3. All right, let's do this. 15 divided by, you know what? It's easy enough to write 0.00, sorry, 2 zeros, 371. Okay, our section is how much? 4.04 times 10 to the what? Which is already in what? in kilo ohms. It just happened to be. All right. So that's equal to 4 point, is it 0.5 or 0.4? 0.4. All right. 0.4 times 10 to the 3 ohms, which is 4.04 kilo. Kilo, because this guy right here is just this guy. Nice. So now I know that if I want to squish both resistors, I could just squish them using a what? A stand-in 4.04 kilo ohm in their place together. So how can I know now the resistance of the missing one? Why? Because they are connected in what? In series. If I know the total thing for the in series and I know one of the players, I can know the other player. Kind of like conservation of energy. If you know one part, you can know the other part. All right? Oh, we're going to do a parallel. The next worksheet is both of them have parallel in them. Okay. So what is the resistance of the other resistor? Well, we know that Req is equal to what here? R1 plus R2, which implies that, now which one did we say that's the missing one? We said R2 is the missing one. All right. So R2 equals Req minus R1, which is equal to, now they wanted in what already? They want the final answer in what unit or what scale? Kilo ohms. Well, I've already been given R1 in kilo ohms, and I just found our EQ in kilo ohms. Let's just use kilo ohms. So 4.04 kilo ohms minus 1.40 kilo ohms. So really just 4.04 subtract 1.4, that's 2.64. Yep, 2.64. In what though? In kilo ohms. Okay, here's another question. What's the voltage across each resistor by itself? What's the resistance? Sorry, what's the voltage? So everyone, now I want you to imagine this. Look, everyone, now I want you to imagine you put two hooks here and also what? Two hooks here. What formula do I use? Can I use V equals IR? I think so. Let's think about this. Do I know each resistance now? And do I know the current through each resistance? Yeah, it is it is 3.71 before, through, in the middle, through, and after. Which means what? For each resistance, I know the V and I know the I. Sorry, I know the I know the R, so I can get the V. All right. So V1 equals what? I1 times what? R1, which is equal to 3.7, 3.71 times 10 to the negative 3 times 1.4 times 10 to the 3. Remember, this is a milli and this is in kilo ohms. Okay, this everyone, this part is I1. This part is R1. Do you know what's going to happen to 10 to the negative 3 times 10 to the 3? You can either think of it as they're going to cancel out, or they're going to give you what? What's negative 3 plus 3 when you add exponents? 0. What's 10 to the 0? What's any number to 0? 1, which is why they cancel out. So either you think about it this way or that way. So my point is, I'm going to end up just needing to multiply this guy by this guy. So because they're decimals, I'm not sure what the answer is, so I have to plug it in. 3.71 times what? Times 1.4. 5.194, but we have only 3 sig figs through the whole thing. So just what? 5.91 or 19? 19. Yeah. In what unit? Volts. I'm already telling you. Volts. Can I do the other one the exact same way? 100%. It's the same current, but a different resistance. All right. V2 equals I2 times R2, which is 3.71 times 10 to the negative 3. That's I1. But now times, what was it? 2.64, yes. 2.64. Also times 10 to the 3. So the exponents will cancel, which means I just need this guy and this guy. So 3.71 times 2.64. 9 point what? 7. Well, if I want. By the way, okay, you know what? Everyone, listen up. I noticed something in your tests usually and quizzes. If you round incorrectly, like Muhammad, what Muhammad just said, you said what? 9 point what? I think you said. Oh, you said. Oh, sorry. You said 9.8, which really should have. Okay, everyone, listen up. Could we round this to 9.79? Everyone, eyes on me. Ladies, it is 9.79 if you really want to be technical. What's wrong about saying 9.8? Two things. First, the rounding is incorrect, right? What also is incorrect? The number of what? The number of what? Sig figs. Whenever you round incorrectly, everyone, I never take marks off. You can run through all my quizzes and tests. If you round incorrectly, I never take marks off. When do I only take marks off? If you make a mistake with the what? So if Nadim said 9.80, you get full marks because you get the number of what? Sig figs. But your rounding is not correct because when you cut a 4, the 9 does not get affected. Make sense? But I'd like to always make sure you get both right. Okay? So it's 9.79. Here's a question for you, everyone. Listen up. Add these numbers for me. Everyone, let's add these numbers. 5.19 plus 9 point. What do I get? What do I get, everyone? Which is very close to what? Does that make sense? Yes, the whole thing. How much? Which means if one of them is like 7, the other one has just to be the what? Has to be the what? So could I have done this in a different way? Part 2. How could I have done it? I could have subtracted 15 minus what? Minus 5.19, which will give me 9.81, right? Because of the round. But either way, both are correct. Everyone, what if I had 3 resistors and I only found 1 and I still missed 2? Can I subtract then? No, because I don't know how the other 2 will play out, right? So always, if you have more than 2, you need to use it this way. You need to do it this way. If you have 2, you can just find 1 and subtract. All right? Okay, everyone, the last, just one thing new. The last thing I need to teach you, listen up. The last thing I need to teach you in what? In this unit. What's the question here? Asking for what? Power. How much wattage is, what does dissipated mean, by the way? Anyone knows the word dissipated? It's simple. Say again? Lost or basically spread over, okay? When you dissipate, things are spread over. So the question is saying, how much power is lost through what? Through each, like if you touch each resistor, how much heat loss in watts would you feel? So we need what? Equations for what? Power. Did I teach you equation for power before? What's the equation for power? Delta E over delta T. Okay, I'm going to teach you, actually in circuits, we have 3 equations for power. It's interesting. Everyone look. Everyone. Here's the first equation for power. P equals what? I times. By the way, how can you check that this equation is correct? Can we at least do the units? Yeah, all right. Everyone check this out. P equals IV. Can someone tell me what's the equation for, so what's the unit for I? Come on. Amps. All right, amps. What's the unit for voltage? Volts, okay. Okay, does anyone remember what's a single amp? You kind of need to go back to the what? To the Q over delta T equation. I'll tell you, a single amp is what? Is a single coulomb over a single what? Over a single second. So 1 coulomb over second. All right, what's voltage? Voltage is energy over test charge. So what's energy? Come on, joules. And what's charge? What's going to happen to both coulombs? they're going to cancel out. So what do we survive with? Joules per, and that's the unit for what? Because that's equal to a what? A single watt. Okay? So that equation is correct. All right. Here's my question to you. Don't we already have this equation? Can we plant an equation into another equation? Yes, we can. Everyone, look. If I replace this V with what? What's I times I? Great. Here's another equation for power. Okay, here's another way also. Can I now replace I with V over R? How many people agree that this is also correct? Yeah, okay, I agree. No, you're right. Is that correct now? Okay, who is not seeing this? Who is not getting what I just did on the last step? Please raise your hand. All right. Nadeem, what's Ohm's law? V equals what? V equals I times R. So I is equal to what? V over. So I just replaced the I here with what? I'm trying to create more equations by combining two equations together. So that's it. Now, how can I multiply those two? What's technically under this V? 1. Yes, 1. Which means V squared over. How many equations do we have for power? 3. Everyone, listen up. What's so good about having 3 equations? You can use them depending on whatever givens you have. So for example, look, if you have I and V, which equation do you use? This one. What if you have I and R? What if you have only the I and the R? Then you use what? This equation. What if you have V and R? Do you see what I mean? As long as you know 2 things about each resistor, you're fine. You can calculate power. Which one is the easiest one to do? The first one, because just I times a V. There's no squaring, there's no division, nothing. Okay? So I want you to write this, everyone. I want you to write those 3 equations in somewhere in this worksheet, or maybe if you go back to your notes or something, but have them definitely accessible. P equals IV, P equals I squared R, P equals V squared over R. They are all the same thing. Same. Yeah, Lindsay is writing them near the diagram because there is space. Go ahead, but have them somewhere. Those 3 are literally the 3 same ways of saying the same thing. Okay, let's use the first one. All right. Clean up. All right. So the first one, P1 equals I1 times V1. What's the current through the first resistor? Current through 3.71 times 10 to the negative 3. What's the voltage of the first resistor that we found out in part D? Sorry, in part E. How much? 5.19, yes. So let's see what answer and what do we get? 3.71 x 3 minus times 519. 0.0193. Remember, 3 sig figs. This is not a sig zero. This is not a significant zero. We start counting from here. 193. So only 0.0193 watts have been lost in this, what do you call it, in this resistor. Same thing with this one. P2 equals I2, V2 equals this number now. So 0.00371 times 9.79. 0.0363. 2 doesn't do anything. Done. How can we check all of these answers? What do I have open already? The simulation. All right. So everyone, by the way, the simulation might not give me the powers, but gives me everything else. All right. So let's do this. Um, okay. The volt. What was this one again? How much? How much was the other resistor? Exactly. So 2000, 2.64. So 2600. Sorry, 640. Okay. What should I do to the switch? Look. Okay. What's the current? Can someone see it? 3.71. In what unit? Milliamps. Got it. Okay. Um, 2.64 kilo ohms. Power 363 what? Milliwatts, which is exactly what we got. Sorry. Oh, why is it? Oh, my bad. Oh my god. Yeah, I don't know why I just clicked. You can refresh. But does it make sense now how you can use this to check your answer? Awesome. All right. We are done with, in good time, we're done with practice worksheet number 5. Let's go to number 6. Come on, everyone. Let's go to practice worksheet number 6. We have this circuit. Can someone tell me what parts do you see on the circuit? Like what electric parts does this circuit have? Come on. What do all of these symbols mean? How many resistors do we have? 4. How many of them do we know? And how many is missing? Okay. Does anyone know what's that symbol on the left? No, no, the switch is always like this. It's like the switch is always this guy. But what is it, what I'm not asking what's the meaning of the symbol. I'm saying what is the symbol of? This is a battery. This is what a battery is. Everyone, the long line is the positive terminal. So then the small line has to be the what? Okay, did I even tell you how much the voltage of the battery is? Yeah, because we're doing a resistance problem now. We're not doing a what like a circuit problem. Okay, everyone, oh, are the resistors big or small? Resistors, are they big or small? Okay, perfect. So that means um oh okay, sorry, forget that question. They are small. All right. What's the question here? How much should this one be? How much should this one be for the what? For the entire circuit to be how much? 20. Okay. Are those connected in series or in parallel or mixed? Okay, okay, by the way, you might listen up. You might ask, I always put my diagrams where? In the middle of the page, right? How come I'm actually showing it this way? Because I'm going to show you now how to resketch the circuit, but with what? With a simpler diagram. Are there two resistors here I can combine easily right now? Which one? The 7 and 9, because they're connected in what? In series. So what's the combined equivalent resistance of both of them? Great. So I want you now to go here like this. This one becomes, I'm going to sketch the same thing, but instead of 2 here, I'm going to just sketch what? Just 1. Good. So, by the way, again, leave some space because there's a third diagram coming. Okay? I'm going to do it here to give myself space. So follow my lead here, everyone. Go. That's it. By the way, resketching circuits is the most important skill you have to actually know when you actually what do circuits. Because you can take all of these big combinations and simplify them step by step, kind of like simplifying fractions. Okay, do I know this one yet? Do I know the top one yet? No, so I'm still gonna call it R. But do I know this one now? What is it? So this whole thing, sorry, not whole, I mean this small combination becomes 16. So I'm gonna write it in green to 16 ohms. Did this one change? No. So it's what? 14 ohms. Okay. What's my next step? Okay, who else other than Ali knows what our next step should be? Okay, Ali, go ahead. Could I now compress the two in parallel? Yes. Okay. Everyone, I'm gonna show you the easy way to do this. So let's resketch the circuit. So how many people agree that the simplified circuit should look like this now? Remember, you might be uneasy about this. Why? Because you might think, yeah, I get how you made these two into a single one like this along the same wire. How can you make this one also along the same wire? Because I took it, somehow added those two in parallel, and then just what replaced it with a single one. With a single one, you compressed it. And here's the thing: do I know this one yet? I don't. I know this one. How much is this one? 14. Do I know this one yet? Okay. I want you to put a question mark and stop right there. Yes. Oh my. Say again. See, that's the thing. That's what I'm going to talk about right now. The 16 and the R have been combined, but I just want to show you how they were combined. Okay, everyone, pencils down. This needs to sink in because this will be a test problem. Okay. The whole circuit is how much? The whole circuit apparently needs to be how much? The whole circuit needs to be 20. Okay. Those two are connected in what? Those two connected in what? In series. One of them is already how much? So what's the only possible choice for this guy? How much? Do you see how we simplified the way we look at it? Instead of looking at the whole thing at once, I compressed it twice, and then I was like, wait a minute. I know that the whole thing, by whole thing, I mean these two must be what? 20. This is how much? And they're connected in series. So the question mark has no other choice but to be what? But to be what? 6. And that's what we can actually deal with now. So basically, I want you to write this. So, yes, go ahead, please. No, you can't. Everyone, parallel means they actually have to be part of the same stack. Parallel, two ones in parallel must be part of the same stack. This and this are not part of the same stack. Okay, remember, a part of this the stack is only the members of the parallel one. Okay, so this is how we're gonna start writing now. Since, okay, everyone, go ahead. Since would be 6. Yeah, I'm with you. And that's what's gonna lead me into a simplified way of solving it. I just want you to write this and let it sink in. Since the REQ, sorry, since the R since the R whole is 20, the question mark must be how much? Okay. So since the whole thing is 20, the question mark is 6. But here's my question. The question mark was how many things? 2. And they're connected in what? Parallel. Can someone remind me what's the equation for parallel? Exactly. We have to what? We have to flip. So okay, I need this to sink in here. What I just wrote right now. How come I didn't write this? Because this would only work if they're connected in what? In what? In series. And by the way, could that ever happen? Can you ever add 16 plus a positive number and get 6? No way. So there's no way to produce a 6 using a 16 and something else. Even if it was what? Even if it was 0, sorry, 16 plus 0 is 16, not 6. So the only way to do it is to do it in what? In what equation is this? Series or parallel? Parallel. Okay. Physics is done. How do you solve this using math? Seriously, there's absolutely no more physics here. You know what? Let me put your mind at ease here. How do you solve this? Someone gives you this in grade 11 function, which, by the way, could happen and probably already happened. How do you solve this? Don't think physics, think math. Come on, people. Say again? But how come you can do that? It's a fraction. No, you're right. It is. People, are fractions numbers at the end of the day? Yeah, fractions are numbers. They just look different. But they're still what? They're still numbers. Can I put numbers together? I can do nothing but always put numbers together. Perfect. So that means what? Here's how we do it. So I'm going to have to move this guy with the plus sign, which is going to turn into a what? Yes. Those two. Okay, okay. Look, Matthew, let's do a quick review from yesterday. Would take more than a minute. Question for you. Those two are connected in what? Come on, everyone. Good question. I'm pretty sure some of you have it. Those two are connected in what? Series or parallel? Because there's a flip, not a flip, a split, I mean. Okay, so if I asked you, somehow I want to compress those two into a magic single one, like this, okay? My question to you is, what red resistor could you replace that could exactly stand in for the same effect as those two split ones have? Well, I would say what? 1 over Req equals what? 1 over 10 plus 1 over 20, right? Make sense? Okay, no. Okay, whenever you connect two in parallel and you want to take them away and put one that exactly matches their effect, this is the only way to what? To calculate the replacement one. I know that, again, I said it yesterday, there's a lot of blind faith here. And if we had more time, I would really explain why. I just want you to believe this. If you have two connected in that specific way, and you want to take them both outside of the circuit because they're occupying too much space, and you just need to replace them with what? With one single resistor like the one I showed you yesterday, you need to get yourself a resistor calculated using this equation. Okay? That's all. Trust me. You just do it enough number of times. Again, why will not sink in, but at least you'll get every question right. Okay? So my question here is, R and 16, they're connected in what? Parallel. And I just said that both of them should be what? 6, because that's what's remaining after the 14 steals from the 20. Okay? So that means 1 over 6 equals 1 over R plus 1 over 16. Okay, so Asser said move the 116 to the other side. So that means 1 over 6 subtract 1 over 16 equals 1 over R. Next, Come on. Final, do fractions. Okay. Do 6 and 16 have a common denominator? Sadly, yeah, exactly. I need to go, yeah, not between them, but I need to multiply each one. So what's the number? 48. 6 times 8 and 16 times 3. So that means times 8 times 8 times 3 times 3. All right. So 8. What's my next step? What's 8 minus 3? How am I going to solve this? How do I solve that? Crisscross or cross multiply? Yeah, no, 9.6. Uh, didn't we just get 2.64 kilo ohms for one of them and 4.04? Oh, sorry. Oh, what is it? Oh, it's this guy. That's the whole idea. What do I put here to make sure that this entire circuit is as equivalent as a 20 ohmer resistance? That's what we're trying to find this guy. If you put more or less, you're not generating a 20. You're generating either more than 20 or less than 20. But 9.6 is the magic number that makes sure that the entire thing is 20. Yes. Uh-huh. Yeah. Let's do that. Everyone, I was waiting for someone to ask me, how do I know that my answer is right? Let's do this right now. Everyone? Yeah, that's no, that's basically checking my answer. Everyone, pencils down. Ladies, pencils down, just look here. We said that the answer is how much? So 9.6 and 7 and 19 will be compressed to what? Okay, I need someone to tell me how to calculate the equivalent resistance of just these two parts. 1 over. So 1 over Req equals 1 over 9.6 plus 1 over 16. If you're worried about having a fraction in a a decimal in a fraction, that's fine. I'm just gonna actually do it using this right now. Here I go. I'm gonna use. Okay. By the way, can you still do common denominators with decimals? Yeah, it's still a number. It's still a number. By the way, does anyone know what's the easiest way to get common denominators? Just multiply. Thank you. Just multiply both of them together. Okay, let's multiply both of them together. 1 over Req equals. All right. What's 9.6 times 16? By the way, I did not need to do that. You know why? Because 96 accepts 16 as a divider. I could have done that. Okay, but let's say you didn't see it and you multiplied. How much? 153 point what? Point 6. 153.6. So 16 plus what? All right, almost there, everyone. Look. What's 16 plus 9.6? 25.6. What should I do now? Come on. Or By the way, does everyone agree that we can do this? How many people agree I could have done that? Yeah, instead of crisscrossing, if you flip one side, you should flip the other side. Can I cross multiply now? I'm going to have to cross multiply either way. But what's the good news? I have a 1 here. So let's actually what? Just what? Divide. What did I get? I got 6. Which we already said they should what? Compress to 6. And what's 6 plus 14? The whole circuit is 20. That's the only way to check it. Like, oh, no, I was just checking my answer. I just made sure that it gives me 6, which added to 14 will give me 20. Yeah. Well, they were there. I just compressed them quickly. That's it. Yep. Okay, everyone, come on. Before break. Is this the exact same structure? How many people say no? How many people say this is the exact same structure as the one on top? Raise your hand if you think so. How come it looks different? Yeah. Do I still have a single one on top here? Do I still have a single one on top? Do I have 2 in series here? Do I really care that this one now is placed at the bottom? No, because could I just drag it and put it up here? There you go. The spacing of the parts does not matter. Okay. How can I simplify the diagram? Which 2 do I compress first? Everyone, which 2 do I compress first? Come on. Resketching. Which 2 do I compress? The 2 at the bottom because they are in series. Oh, by the way, the easiest one to always compress are the series. Okay. So I'm going to do, I'm going to put it right here. Okay, everyone, come on, let's resketch. Yes, 4 plus R. I don't have a choice. Okay. 4 and the 10. Because they're not connected in series. You see? There is a split. No. It's not just the R that's in parallel with the 10. It's the 4 plus R. Again, that's why circuits are tricky. People are like, oh, that's in parallel. No, the whole thing is in parallel with the top part. Okay? All right. Okay, everyone, I'm going to resketch. Come on, sketch with me. Let's not waste time. So, battery. Okay, what numbers don't change yet? What numbers do not change yet? The 10 and the 20. Layla, what did you say this one becomes? Yeah, 4 plus R. For some reason, some people say 4R. Why is that incorrect? Because that's multiplying. Exactly. No, it's adding. Can I compress again like I did in the top one? Yes. This thing now is compressed with a question mark in parallel. All right. Again, let this sink in. It got somehow it got black boxed compressed with the what? With the 10. But by the way, again, I am trying to look at a small thing first and then expand on it. That's say it. No, I can't. You know why? Because 10 and 4 and R are not connected in series. That's why I'm leaving it as a question mark for now. Everyone, what's the whole thing supposed to be? The whole thing is supposed to be that bottom one is 20. What's the only choice for the top one? Again, I want you to look at this one. Isn't that the same thing we thought in the first one? The first one was 20 in total. 14 was one of them. The question mark was 6. Here, 20 is one of them. 25 is the whole thing. So this thing must be what? Must be 5. What? No, those two are connected in series. The current does not split between them. Layla, remember, to Asser's point, everyone look, everyone, could I have just deleted the, sorry, oops, did not mean that. Could I have just deleted this one and place it right here? Sorry, no, yes. Why not? Does it matter where the resistor is on the line? No, which means what? I could have placed it here, 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 or even here. Okay, so, but I'm going to keep it where it used to be just to make sure that you do not get what? Fixated on moving them too much. Okay, everyone. Can I write this statement all over again? But can someone tell me how it's going to read now? 25. The question mark must be? Good. All right. Since type it down. Since REQ is 25, the question mark five must be, yeah, must be 5. So can someone tell me, everyone, listen up. Can someone tell me what did the question mark used to be? Used to be. Yeah, like before we resketched, what did it used to be? It used to be 4 plus R on the bottom, and then what? 10. All right. So that means what? Everyone, can I still write something like this? But eyes on here, guys. Ali, can someone tell me how this one's going to change? Before you answer, I'll give you a hint. Here's the new diagram. Sorry, is it 10 or 4? Is that correct? Okay. How are you going to change things? What is the 6 going to become? Nice. The 6 is going to. What is the R going to become? 4 plus R. Or 10, right? Either one. But one of them has to be what? 10, and the other one has to be what? 4 plus R. All right? Because they are in what? Because they are in parallel with a 10 on top and a 4 plus R at the bottom. No, no, no. Those two are in series. I'm talking about the entire group. The entire group is in what? Parallel. There is one part of it we don't know, and we're about to find it just using math. Say in. Everyone, I just need to hear tell. Because it's 5 now. It used to be 6. Now this whole group is 5. How much is this? How much is this? Whole thing. So that means this big chunk is just what? So that whole thing as a whole, I try to just look at what I need to look at. Okay, all right. So 1 over Come on. So, what did I write exactly? So, okay. 5 equals 1 over 4 plus r plus 1 over 10. Asser, what's my first step? Like you did before. Bring the 110. Come on, everyone. Let's do this in 1 minute. Bring the 110 to the other side. 1/5 subtract 110 equals what? Does anyone know what's 1/5 minus 110? Yeah, because like 1/5 is 20 cents minus 1/10 is 10 cents. I mean, or you can do it in decimals or in fraction, but it will be what? It will be 1/10. How? Common denominator is 2 and 2. Sorry, times 2 and times 2. All right. So that gives me what? 2 tenths minus 1/10 equals 1 over 4 plus r. Does anyone see how simple it is now? What are my two numerators? Both ones. If the two tops match, what can you say about the bottom tops? So about the bottom. If the two tops match, then the what? Then the bottoms have to match, which means right there, 10 equals what? Which means r is equal to what? R must be 6 for the entire combination to be what? To be exactly 25 ohms. Thank you. Okay,